Lesson 63, solving systems of linear equations by elimination. So we looked at solving systems earlier by graphing. We've also used substitution. Another method is using elimination. And so we're going to go through the steps today on how to use elimination to find the answer to a system of linear equations. So this one sample has been done for us. Our step is to solve by eliminating one of the variables first. So we have two equations, 5x plus 2y equals 9, and 5x plus 6y equals 7. And one of them is, the second one is a negative 5x plus 6y equals 7. And since your ultimate goal is to make sure that one of the variables, such as this x right here, they have the same number, same variable, but opposite signs. That's how you would eliminate one of the variables. So you only have one variable left. And then you add straight down. So 5x plus a negative 5x is 0. 2y plus 6y is 8y. 9 plus 7 is 16. To solve for y, you divide by 8 on both sides. Y would give you 2. And then you substitute 2 into one of the two equations above. It doesn't matter which one you choose because you'll still get the same answer. I chose to put it in the first one. I put 2 in for x, or for y, and solved for x. So 2 times 2 is 4. So I subtracted 4 on both sides, and you get 5x equaling 5. Divide by 5 on both sides. That's how we get x equaling 1. Let's try one ourselves. Solve and check. So the first thing I want to look at to see if I have any variables that have the same number but opposite signs. And in this case, the y's have the same numbers but opposite signs. So I can add those together. 3x plus 6x is 9x. The y's cancel off because it equals 0. And then I am left with 27. To solve for x, I divide by 9, both sides. X would equal 3. Now I have to substitute 3 into one of the two equations above. I'm going to use the top one. So 3 in for x plus 7y equals 16. 3 times 3 is 9 plus 7y equals 16. You get 7y by itself. I'm going to subtract 9 on both sides. End up with 7y equals 7. To get y by itself, I divide by 7. Y would equal 1. So this would be my answer, x 3, y 1. You could have also put your answer as an ordered pair, so then you would write it as 3, 1. That's up to you how you want to write it. Just make sure if you put it as an ordered pair, you put them in the right order. Try a second one. 7x minus 4y equals negative 3, and negative 3x plus 4y equals negative 1. I can cancel out the y's or eliminate the y's because they have the same number but opposite signs. So add straight down. 7x plus negative 3x is 4x. Y's cancel out. Negative 3 plus a negative 1 is a negative 4. To get x by itself, I divide by 4. X would equal a negative 1. Need to substitute. I'm going to use the bottom one. So negative 3 times a negative 1 plus 4y equals negative 1. Now we simplify. Negative 3 times negative 1 is 3 plus 4y equals negative 1. To get 4y by itself, I subtract 3 on both sides. I get 4y equaling a negative 4. To get y completely by itself, I divide by 4. Y also equals a negative 1. So x negative 1, y negative 1. Now let's move on to subtracting equations. So here you'll have a variable that's exactly the same with the same signs. So that means we have to distribute a negative 1 on one of the equations so that we can eliminate one of the variables. So here they distributed -1 on the bottom, second equation. So then it made it -2x, a -3y, and a -5. And then you just add straight down. And so there you can see the steps that they used. But we're going to do one ourselves. So here, -2x plus 2y equals 18. The second one is -2x minus 7y equals 9. And I already put down here that we need to distribute a -1. So I need to distribute this -1 here. So I'm going to rewrite the problem. So I have a -2x plus 2y equals 18. That was the top equation. The bottom one, so if I distribute a -1, this makes it a positive 2x, a positive 7y, and a -9. Now I can add straight down. The x's eliminate. 2y plus 7y is 9y. 18 minus 9 is 9. To get y by itself, I divide by 9. Y equals 1. Now I can take one of my equations. I'm going to take the top equation. So -2x plus 2 and put my y in, which is 1, equals 18. So -2x plus 2 equals 18. Get -2x by itself, I subtract 2 on both sides. -2x equaling 16. Get x by itself, I divide by -2. X equaling a -8. So my answer would be x is -8, y is positive 1. Let's take a look at a second example. Same thing, the bottom one, we need to distribute to -1. So I'm going to rewrite my whole problem. So I have 11x plus 6y equals 21. Now I have to distribute a -1 here. So this would be a -11x, a minus 4y, and a -25. Now before we solve it, we're trying to determine, am I going to be subtracting the equations or adding the equations? It's all based on what you see with the variables. If you see that the x's are exactly the same in both equations, or the y's are exactly the same, then you need to distribute a -1, which means you're going to be subtracting the equations. If they're the same numbers but opposite signs, then you're just adding. So that is your clue that you need to look for. So now I subtract. So 6y minus 4y is 2y. 21 minus 25 is a -4. To get y by itself, I divide by 2. Y would equal a -2. And then I got to choose an equation. I'm just going to choose the top one. So 11x plus 6 times a -2 equals 21. So 11x plus or minus 12, because 6 times a -2 is a -12, equals 21. To get 11x by itself, I add 12 to both sides. Get 11x equaling 33. To get x by itself, I divide by 11. X would equal 3. So that would be our equation on that one. Next one, multiplying one equation. So sometimes the variables are not going to be the same, and so we need to multiply one of the expressions or one of the equations by a number so that we get the same variable with opposite signs. Now you can see in this example that we have to rearrange, because you have to make sure that your x and y is on the same side of the equal sign. So there we need to rewrite that. So we have 5y minus 8x equals -2. And then you have your 4x minus 3y equals -2. Since the x's need to be the opposites, I know that the common factor, or the greatest common factor of 8 and 4 is 8. I don't have to change anything with the 8x. I need to make the 4x to become a positive 8x so I can eliminate the x. So I multiply everything by 2. And when I do that, 2 times 4x is a positive 8x. 2 times a negative 3y is your negative 6y. 2 times a negative 2 is your negative 4. And then you can just add straight down. 5y plus a negative 6y is negative 1y. The x's eliminate. Negative 2 plus a negative 4 is a negative 6. Divide by negative 1. That's how we get a positive 6. And then you just substitute the y into one of the equations above. Let's try one ourselves. Solve this one. You may need to rearrange first. So I'm going to rearrange this one. So I need to add the 2y to both sides. So now my new problem, I'm going to write the first one first. So 3x minus 6y equals 18. And on the bottom one, I have 5x plus 2y equals 6. Now here you can determine, do you want to eliminate your x's or your y's? I would do the y's because they already have opposite signs. And I know that all I have to multiply is the bottom equation by 3, because 3 times 2 is going to give me a positive 6y. So now if I distribute, this will give me 15x plus 6y equals 18. And then I'm going to put this second one down here. So it would be 3x minus 6y equals 18. And now I can add straight down. So 15x plus 3x is 18x. The y's cancel off. 18 plus 18 is 36. I'm going to put this up here. So 8x equals 36. The x by itself, I divide by 18. X would equal 2. And then I substitute 2 in. I'm going to choose this top equation. So 3 times 2 minus 6y equals 18. This will be 6 minus 6y equals 18. Subtract 6 on both sides. Negative 6y equals 12. Divide by negative 6 on both sides. Y would equal a negative 2. Let's try another one here. Here, since the x and y are on both sides, I don't need to rearrange. I do need to multiply, and here I'm going to eliminate the x's. Because I only want to multiply one of the equations right here. Because I know a negative 2 and 6 the greatest common factor is 6. So I just have to multiply this top one by positive 3. When I do that, 3 times negative 2x is negative 6x. 3 times 5y is a positive 15y. 3 times 6 is 18. And I'm just going to add these bottom two. The x's eliminate. Negative 2y plus 15y is 13y. 34 plus 18 would give us 52. To get y by itself, I divide by 13. Y would equal 4. Then I'm going to substitute y into one of the two equations. I'm going to choose this bottom one here. So 6x minus 2 times 4 equals 34. So 6x minus 8 equals 34. Add 8 to both sides. And I get 6x equaling 42. To get x by itself, I divide by 6. X would equal 7. So it's x equals 7, y equals 4 would be our answer. Now the next step would be, what if we have two equations that we have to multiply both equations by a number. So we can get a common factor, the greatest common factor, and eliminate one of the variables. So here, you can either eliminate your x's or your y's. It does not matter, but whatever you're going to eliminate first, you get to find the greatest common factor of those, or the least common factor. Common factor here, eliminating the y's. So the common factor of 3 and 5. And the reason why I chose the y's is because they already have opposite signs. So I had to, common factor would be 15. You could have done more, but I usually choose the smaller of the factors. So negative 3 and 5 would be 15. So I need to multiply this top one by 5. That's what you see here. The bottom one I have to multiply by 3. When you do that, you can see that I can eliminate the y's, and you have 38x equaling 0. Divide by 38, x would be 0. Plug the 0 back into one of the equations to find your y. So let's try one ourselves. 2x plus 2y equals negative 8, and negative 5x minus 3y equals 14. Since both of them have opposite signs, your x's and your y's, it doesn't matter. I'm going to choose to eliminate the x's. So I have to figure out what is the common factor of 2 and 5. I know 10 is a common factor, so I'm going to multiply this top one by 5, this bottom one by 2. So 5 times 2x is 10x, 5 times 2y is 10y, 5 times negative 8 is negative 40. And then distribute the 2 on the bottom one, so 2 times negative 5x is a negative 10x, 2 times a negative 3y is a negative 6y, 2 times 14 is 28. Now I just add straight down, so 10x plus a negative 6y, or 10y plus a negative 6y is 4y. Negative 40 plus 28 is a negative 12. Get y by itself, I divide by 4. Y would equal a negative 3. And then I just substitute that into one of the two equations. I'm going to choose the top one. So 2x plus 2 times a negative 3 equals negative 8. So 2x minus 6 equals negative 8. Add 6 to both sides. I get 2x equaling a negative 2. Get x by itself, I divide by 2. X would equal a negative 1. So that would be our answer. Let's try another one here. Negative 8x minus 3y equals 26. Negative 5x minus 2y equals 16. So I check to see my signs. All of them are negative. Now I have to determine which one do I want to eliminate, the x's or y's. I'm going to choose the y's this time. But one of them I have to multiply by a positive number, and the other one I have to multiply by a negative number in order to get opposite signs. So I'm going to multiply the top one by a negative number. And so if I look at negative 3y and negative 2y, common factor would be 6. Or a common multiple, yeah, common multiple would be 6. So I'm going to get 6, I need to multiply this by negative 2. To get negative 2 to be a negative 6, I need to multiply this by 3. So I distribute negative 2 times negative 8x is a positive 16x. Negative 2 times negative 3y is a positive 6y. Negative 2 times 26 is a negative 52. And then 3 times negative 5 is negative 15x. 3 times negative 2y is negative 6y. 3 times 16 is 48. And now you can see that my y's eliminate. I have 1x equaling a negative 4. So x would equal negative 4. And then I substitute that in there. I'll use the bottom one. So negative 5 times negative 4 minus 2y equals 16. So 20 minus 2y equals 16. Subtract 20 on both sides. Negative 2y equals negative 4. To get y by itself, I divide by negative 2. Y would equal a positive 2. So there, I had to multiply both equations by a number. Again, it doesn't matter which equation or which number or letter that you eliminate first, as long as you multiply each equation by a certain number that gives you opposite numbers that you can eliminate. Now let's look at some application word problems. Carlos has 32 buffalo nickels, some with dates and some without dates. Buffalo nickels without dates are worth 15 cents. Dated buffalo nickels is worth 75 cents. If Carlos's collection of buffalo nickels is worth $10.80, how many of the coins have dates on them? So I need to write two equations. I'm going to use D for dated, and I'm going to use W for without dates. So I have dated nickels and without dated nickels. That would equal, if you add them up, that gives you 32 nickels. Okay, just using this first one. Says the buffalo nickels without dates are worth 15 cents, so 0.15 W. And the ones with dated are worth 75 cents, so 0.75 D. And this has to equal a total of $10.80. So now I have two equations. I want to eliminate one of the variables. So I'm going to eliminate the W. So that means I have to multiply this top one by a negative 0.15 because the bottom one is positive 0.15. So if I distribute here, I end up with a negative 0.15 D minus 0.15 W equals, and then take 32. 32 times a negative 0.15 gives us a negative 4.8 or 4.80 since we're dealing with money. Now I can add straight down. 0.75 minus 0.15 would be 0.60 D equals 1080 minus 480 would give us $6. Divide by 0.6, so our D would equal, so 6 divided by 0.6 give us 10. So I have 10 nickels that have dates on it. Now I can choose the top equation, put 10 in for D, plus W equals 32. Solve for W, subtract 10 on both sides. W would equal 22. So I have 22 nickels without dates, 10 nickels with dates. And the last one here, a movie theater sells 540 tickets to a matinee showing of a new animated feature. A child matinee ticket costs $5.50 and an adult matinee ticket costs $6. If the movie theater made $3,060 for that showing, how many adult tickets were sold? So adult tickets plus child tickets equals 540 tickets. So one of the equations has to deal with all tickets. The second one, it deals with all money. So an adult ticket costs $6, and the child ticket is $5.50, and the total amount is $3,060. So I need to multiply this top one by, let's eliminate the adult ticket. So I need to multiply by a negative 6. Since the bottom one is a positive 6. So this would be a negative 6a and a negative 6c. 540 times a negative 6 is a negative 3,240. Now we can add straight down. The a's eliminate. 550 minus 6 is a negative 0.50c equals 3060 minus 3240 gives us a negative 180. Get c by itself, divide by negative 0.50. And you get number of child tickets sold would be 360. Now I'm going a little bit longer route. Because they're asking just for the adult tickets, I should have just eliminated the C. But let's just say you did that, you eliminated the adults. I can still take my answer for child's ticket to find out my adults ticket. So adults plus 360 child tickets. It's a total of 540 tickets. I just subtract 360 on both sides. And the adult tickets would be 540 minus 360 gives you 180 tickets. So I could have, my only answer for this one is 180 adult tickets. I could have just multiplied everything by a negative 0.55 if I wanted to save a step. So that is our lesson today on solving systems of linear equations by elimination.